In our country, masonry construction is the widely used technique. But this process is slow, labor-intensive, and largely depends on workmanship. And the biggest concern is, in tall buildings, these walls can expand outwards under wind and earthquake loads. Cracks and damage are common. Cracks can affect the structural safety at the junction of infill walls and the RCC frame. To understand this problem, we developed a real condition out-of-plane loading test setup, where actual loading was simulated on AAC block walls, and their behavior was studied in detail. According to the test results, conventional walls crack early and have lower stability. Based on these findings, the solution is optimized with the use of bed joint reinforcement. It is not just reinforcement, but its correct placement, spacing, and anchorage provide the real strength. When used properly, cracks gets reduced, load capacity increases, and the wall becomes more stable. If this approach is adopted on a large scale, houses and buildings across the country can become safer and more resilient. Less maintenance, longer life, and improvements in construction practices without any major changes, simply by changing the way it is used. Moreover, there is no requirement of water and reduces carbon footprint. We can make masonry stronger, safer, secure, and more reliable. This study was undertaken with support from Buildtech Building Elements Limited and Beckert as part of a sponsored research program.